here we go. So 8.3 is trigonometry, maybe my favorite lesson ever. I love trig. I love right triangle trig. The actual like other trig stuff was not my favorite, but right triangle trig is awesome. Okay, here's the first thing you need to know, okay, is just what in the world are sine, cosine, and tangent? Have you heard of them before? Okay. On your calculator, they look like sin, cos, and tan. Those are the three buttons you're going to use a lot. Basically, you just need to understand that trig functions, so sine, cosine, tangent, are a relation. That's a relationship between angles in a triangle, a right triangle. Okay, we're only going to touch right triangles right now. So it's a relationship between an angle and its sides. Okay, these brilliant mathematicians came up with this button, this sine, cosine, tangent. What it does for you is it relates angles to sides so that you don't have to mess with a bunch of just yuckiness. You have a button that will do it for you, okay? It's a relationship between angles and sides. Make sense? Okay, I'll make it make more sense as we go. There are three trig functions. There is sine, cosine, tangent. So I'm going to give you a triangle. And then we're going to lay out the three. And like I said, we are only going to work with right triangles. You'll get more into other triangles when you get to like advanced math. You'll do trig there. That is not all right triangles. But for us, it is only right triangles, and you should be very grateful for that. All right, if these are your three sides, okay, the lowercase is the length of the side. The uppercase is the point, the vertex, okay? Here are the relationships. If I say the sine of angle A, okay, when we're finding the sine of angle A, sine is always the opposite side over the hypotenuse. Okay, so opposite over hypotenuse. Okay, so the shorthand version of this with the letters we're using is we would say sine A. And the trick to this is you always start at the angle we're talking about. So what angle are we talking about right now? A, right? If I'm saying sine A, I'm talking about angle A. So I'm going to start at angle A every single time if it says sine A or cosine A or tan A, okay? So if I'm saying sine A is opposite over hypotenuse, I'm starting at A, and I'm going to do my opposite side from A. So which side would you say is opposite A? A, B, lowercase a, lowercase b, or lowercase c? Lowercase a. Lowercase a, right? Across from angle A, the opposite side is this A. Okay, so sine A is A over the hypotenuse. What's the hypotenuse?
Lowercase
C, right? Your hypotenuse is always across from the right angle, so that is C. So sine A is A over C. Okay? Cosine. So if I say the cosine of angle A, cosine is the adjacent side over the hypotenuse, and I will give you a cute little phrase to help you remember which is which, because I know this is a lot of words. Don't stress about that right now. So cosine A would be the adjacent side over the hypotenuse. You would write that like this: cosine A equals, which side would you say is adjacent to A?
Side B.
B. Why not C? Isn't C next to A?
That's a hypotenuse.
It is next to A, but it's the hypotenuse, okay? So you don't want the hypotenuse to be your adjacent. Adjacent would be from A. Adjacent or next to angle A is side B. Okay? And then it's over the hypotenuse. What's my hypotenuse right now? C. So cosine A is B over C. Okay. Last one is tangent. So if I say the tangent of angle A, that is opposite over adjacent. Okay, opposite over adjacent. Yes, ma'am.
What does adjacent mean again?
Next to.
How do you know if it's C or B?
You need to stop doing your homework. Because I just said that. Just. C is the hypotenuse, right? We don't want the hypotenuse to be the adjacent side because we're going to use the hypotenuse as a hypotenuse. So if it's adjacent, you pick the one that's not a hypotenuse. That's next to. Okay? Okay, so the tangent of angle A, we would write tan A equals, and this one is opposite over adjacent. So what is opposite angle A? Side A, right? This is opposite over here, A. And then what's the adjacent? B. Okay. Here's the trick to remembering sine, cosine, and tangent for what they are. Have you ever heard of SOHCAHTOA? This is where SOHCAHTOA comes in. And there's all kinds of stories you could come up with. There's a chief SOHCAHTOA. There's soak a toe, like stick your toe in water, SOHCAHTOA. I have a whole other story that I could tell you that is like a joke that goes with it. If you want to hear, you won't understand it yet. You have to learn more of this, and then I'll read it to you. Just remind me. Remind me in a few days, and I will read it to you. But you won't get it yet. Like the jokes will go right over your head because you don't know all the stuff. Okay. What I've had, I wish I could remember what student did this because I think it's brilliant, but I don't remember. One of my former students was like, I write it like this. And they do SOHCAHTOA. And I think that's so cute because that's what it is. SOHCAHTOA. If you can spell SOHCAHTOA correctly, you're in really good shape. If you spell SOHCAHTOA wrong, you're going to get a lot of wrong answers. Okay, so make sure you know how to spell SOHCAHTOA. Okay, so it's the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Okay? So SOHCAHTOA. All right. There are a few different ways that you are going to be asked this stuff. Let's do this. First example. Okay, sometimes they're just going to say, what are the sine, cosine, and tangent ratios for angle P? Okay, notice how I'm asking this question because what you'll do a little bit later is not going to be questioned or asked like this, and you do something different. So when they're looking for the ratios, this is what you will do. You will have a triangle that is given to you. And this is P, O, and N. And then your three sides are 8, 15, 17. So you're going to see a lot of Pythagorean triples here, right? 8 squared plus 15 squared equals 17 squared. If I'm asking you what the sine, cosine, and tangent ratios are, I'm saying, what is sine P? And I'm just going to give a ratio for sine P. So if we're thinking sine is what over what? Opposite over hypotenuse. So where do you start with these? Where do you decide I'm going to go from here to find my opposite? From P. You start from the angle. Hear me on this, because I think this is a place of great confusion for a lot of people. They're like, well, which one's the opposite? You start wherever they told you to. They told you we're dealing with angle P. So you're going to start at angle P, okay? You always start from the angle they are asking you about. So if I'm starting at P and I'm doing opposite over hypotenuse, what is my opposite?
15.
15. Opposite would be 15. What's my hypotenuse? 17. So sine P is 15 over 17. Okay, that's all they're asking you for. There's nothing to solve. They just want the ratio.
That was my question.
There you go. Okay, so then let's look at cosine P. Where are you starting?
P.
At P. So from cosine P, cosine is adjacent over hypotenuse. What is your adjacent side to P?
8.
That's the 8, would be next to, over the hypotenuse, which is 17. Okay, and then your last one is tan P. So you are starting again from P, and from P you have the opposite, which is 15, over the adjacent, which is what? 8. So your ratio is 15 over 8. Okay? Any questions on that? Yes, Joseph.
On tan P, would it be wrong if you use 17 since that's...
Yes, because that's your hypotenuse, and tangent is always opposite over adjacent. So you want the opposite side to be your 15. Your adjacent side cannot be a hypotenuse. So if it's going to be adjacent, it has to be the one that's next to P, but not a hypotenuse. Okay? So this one, because this one's across from the 90-degree angle, we're not using it as adjacent. We're using this one instead.
I just thought maybe because we didn't use the hypotenuse.
Yeah, because it's the hypotenuse, you can't use it as the adjacent. Okay? Any other questions on that before I move on to the heart of what you're going to do with this stuff? Okay, here's what you're going to do then. Example 2. You are going to get a triangle. That is not really going to be drawn to scale, but you can use your imagination. This side is 48 feet. This side is X. And we are told that this angle here is 84 degrees. Okay. Your job is to solve for X. And you have the tools to do it. We just got to think through, what does this look like? Where did I say you always start in this problem?
When I tell you to.
At the angle, right? So if I'm asking you sine P, I'm starting at P. Well, for this one, I'm not asking you for a ratio anymore. I'm asking you for a variable, for X, but I gave you an angle. Now, the 90-degree angle is never the angle you're going to use. So ignore the 90. You cannot do it from the 90-degree angle. But if I gave you the 84, we can go there. We can start with that. So if I'm at 84 right now, which two sides, opposite, adjacent, and hypotenuse, which two do you have? What's this side? Opposite, adjacent, or hypotenuse?
Opposite.
That's opposite. Okay. What's this one? Adjacent. So I have opposite over adjacent. You need to choose the trig function that goes with that. That's tangent, right? SOHCA, TOA, that's the TOA part. And if I were you, I would write this on the top of every one of your papers until you get this down pat, okay? Because it will be helpful. This part is your T, okay? So that probably is the most important part of this problem, is did you choose the right function? Because if you chose the wrong one, you will get it wrong, okay? So I'm saying the tangent of what? What came after tan and sine and cosine in our previous problem? The angle, okay? This number after, excuse me, gentlemen, after your trig function will always be the angle. So this is going to be tan 84. Okay, So now we have tan 84, and we said it was opposite over adjacent. What is that in numbers and variables right now? 48 over x. I really should have started with a less challenging problem for you. I mean, this is fine. It's not that it's so terribly hard, but it's just harder algebra that often gets messed up on. Okay, so here's the deal. We want to solve for x. And here's where algebra comes in. And we know algebra, but for some reason we forget algebra. Let's not forget algebra today. If I want to get x by itself, right now it's a denominator. We don't want it as a denominator because it's 1 over x then, right? So we're going to get it out of the denominator by multiplying by it. Okay, so I'm multiplying both sides by x so that that goes away. So right now our problem is x times tan 84 equals 48. Okay? Tan 84 is a number, so you don't want to divide by 84. You want to divide by tan 84. Okay? So I'm going to divide by tan 84 on both sides. This goes away, and I'm left with x equals 48 divided by tan 84. Plug it into your calculator. 48 divided by tan 84. Tell me what you get to the nearest tenth.
5.04.
Nearest tenth would be 5.0, okay? If you plugged it in right now and you did not get 5.0, you're in the wrong mode or you plugged it in wrong. Okay? Anyone need help figuring out how to plug it in?
Can we just put 5?
No, nearest tenth would be 5.0. Okay? We're going to do a whole bunch more of these, so don't worry about it if you didn't get it. Okay. Let's do another one.
That's why it's wrong. It's where it's not connected.
Where's 10?
Okay, do this one with me. If you're having calculator issues, don't worry about it. I will clear those up as soon as we're done with the lesson. You just need to ask me, okay? Here it is.
He doesn't have the 10.
You do. You have a trig button. See where it says trig? No. Trig? You have it. Bring it up here real quick. Do you see it? And then you have to like scroll through to get to them.
Oh, feels.
Okay. This one. Your first job is choose your trig function. So where are we starting from?
Well, we start from 30.
The angle, right? You always start from the angle you have. Which two sides do we have from that angle?
We have a hypotenuse and an adjacent.
You have a hypotenuse, opposite, right? You have the opposite side, and you have a hypotenuse. So that would be sine, right? Because sine is opposite over hypotenuse. So we're going to say sine what?
Side.
Always the angle. Sine 37, okay, equals, what's your ratio?
Opposite is x over 10.
X over 10. Okay, this is the easy one to solve. How do you solve for x right now?
Multiply by x.
Not by x. You want to multiply by 10, right? We want to get x by itself, so we're going to multiply by 10 on both sides. This goes away, and you're left with x equals. You're plugging this into your calculator, and you don't have to hit times. If you plug in 10 sine 37, your calculator assumes multiplication. So plug that in. What do you get?
6.0.
Wow.
Wait, really?
That would be 6.0.
What's all these zeros?
Yeah.
They won't always be that way. I just happen to end up with those numbers.
Crazy.
Yeah.
So how come we didn't have to divide by 10 like we did on the previous problem?
Because that problem, your variable was in the denominator to start, right? This problem, your variable was in the numerator to start. So if it's already a numerator, then when you divide by 10, all you have over there is x. And that's what we're trying to solve for, is x.
Scroll up just so I can see that.
Right? We started with it down here, 48 over x. So technically it's 1 over x then, right? We want to get rid of that denominator status by multiplying by it, and that will make it a numerator, which is what we want. We want something over 1, technically, x over 1, right? Okay? All right, let's do this one. Okay, here's your setup. Which trig function are we using?
Well, you have adjacent and
It's
you have
ka,
hypotenuse.
so ka toa, right? Adjacent and hypotenuse from the angle. So that's cosine what? Cosine 58 equals x on top, right? Adjacent on top, hypotenuse on bottom. How do I solve for x in that? Multiply by 9. So we're going to go times 9, which is going to cancel this out. You're going to plug in 9 cosine 58. That should be 4.8. Okay.
I know, it's pretty straightforward. It's not, it's never too good.
There's one last thing.
Oh.
But this isn't horrible.
There's the dagger.
No, it's not a dagger.
It's just like saying what could go wrong.
Example
Like,
three
there's
is
always
always the
something that
worst.
could go
Okay, here it is. The issue with this one is you have two sides. You don't have the angle associated with those two sides. So if I said find the measure of angle T. Okay. First of all, if there isn't a variable there, I would put a variable there just to help you visualize it. Okay. So angle T is this. Okay. So I'm just going to call it X right now. If we are always starting from the angle, which trig function are we using? Sine, right? SOHCAHTOA, so part of it is sine. So we have the opposite, and we have, the hypotenuse. So I'm saying the sine of what? Angle T, or I'm going to call it X since we gave it a variable. But sine T or sine X, either way, equals what? 7 over 13. Okay. Now here's where you have to do something slightly different, because in order to get x by itself, we have to like reverse the sine function essentially. Okay. Right now we're saying the sine of x equals 7 over 13. Whenever you're solving for an angle measure, you're going to use what's called the inverse of that sine function. Okay. So you can't just say, oh, divide by sine. You can't divide by sine. You take the inverse of it. So technically, you take the inverse of it. It's called arc sine. If you've heard of arc sine before, same thing. But it's this button on your calculator. And for most of you, it's going to be the second key for your sine button. Do you see it? Okay. So you're going to take the inverse sine of your ratio, 7 over 13. And that's going to find your angle measure for x. Okay? So take the inverse of it. Try that out. Tell me what you get. Second key sine, 7 divided by 13.
Wait. How'd you do that?
Typically, we round degrees to the nearest degree instead of the nearest tenth. So if your answer comes out to this, right, it keeps going, we would say x is approximately 33 degrees. Okay? So you literally take the inverse sine or arc sine of whatever your ratio was. Okay? I'm going to do another one. Let me,
Wait, I have a question for
What's this?
yeah.
If it's like 5 or higher, you round it up to like whatever, but it was like 13.4, it should be bigger
32. Mm-hmm.
This is confusing.
Okay, so angle T is x degrees. And I want to know, what is x degrees? What is x? Which trig function are you using? Right, that's cosine. From here, you have the adjacent and the hypotenuse, so that's the part of it, right? So we're going to do cosine what? X, right? The angle, gentlemen, ladies, the angle always comes after the trig function. So cosine x equals what? 8/10. Every single time that you are solving for an angle, you will use the inverse. Every single time. So if I'm looking for an angle measure, I have to use the inverse of that ratio, 8/10. Okay, so x is the inverse cosine, 8/10, or arc cosine, 8/10. Plug it in, what do you get? 37 degrees. Okay, I'm telling you, it's my favorite. I love this stuff.
Yeah, imagine doing this in your four.
Trig is like.
Okay, that's what you're doing. Do you have any questions?